Hi, I'm Sarah, and this is my first video in the series I'm making of Calculus 1 videos. So the first few are going to focus on pre-calculus review, and today we're starting with Intro to Functions. So this is the definition of a function, right? It's a rule that takes every element in one set and assigns to it exactly one element in another set, right? So let's say that this is our set A, and this is our set B. Then for every point x in A, f is going to map it to some point in B that we call f of x, okay? And so every single point in A will be mapped to a point in B. It is not necessarily true that every point in B will have some point mapped to it because, multiple different values could map to the same point, and also B could be bigger than A, all right? So we call A the domain of the function. We call B the codomain. And then there's a subset of B that f actually maps points to, and that is going to be called the range of the function. All right, so that is the definition of a function. The next thing is just the vertical line test. So when we're talking about how to recognize whether a graph is a function, this is the easiest way to tell. So I have two different graphs here, and I have a vertical line. I'm going to take that vertical line and just pull it over the function and make sure that at any given point, the vertical line is only touching the graph at one place, at one point, right? And so for this one, it looks like we're good, right? At any given point, we're touching the pink line at one place at a time, right? Now, for this other graph, here we're good. Oh, and suddenly we're touching in three places. And then we're fine again. And then we're touching in three places. So what we can see from this is that this first graph is a function and the second graph is not. So easy way to always tell just from the graph. The next thing is x and y-intercepts. So the y-intercept is the y value when x equals 0. So that's when the function crosses the y-axis, when the graph of the function crosses the y-axis, right? So we can see here we cross the y-axis here. So this is going to be our y-intercept. Now, x-intercepts are basically the same thing, but for the x-axis, right? It's when y equals 0 and when the graph is crossing the x-axis. So that happens here, here, and here, right? All of these are going to be x-intercepts. And notice that in order to pass the vertical line test, it would be impossible to have multiple y-intercepts, right? Like if we were looping back around and also had a point up here, then we wouldn't pass the vertical line test anymore because literally this vertical line, that wouldn't work. So we can only have one y-intercept, but we can have as many x-intercepts as we want, right? So important thing to keep in mind. And then piecewise functions. So for these, we're basically given these cases, right? Here we have two different cases, but we could have more than that. And so if x is less than or equal to 0, the function goes by this first function, right, up here. So for x is less than or equal to 0. So we're going to have this line here, right? Negative x. Now, if x is greater than 0, we go by this other condition, x squared. So that is a parabola that looks like this, all right? And notice it's just for x greater than 0, so we have an open dot there, but it's filled in by the fact that for negative x, x is less than or equal to 0, and those happen to be at the same point, at the origin. All right, Finally, we're going to talk about even and odd functions. So a function is even if f of negative x equals f of x for every x in its domain, and it's odd if f of negative x equals negative f of x for every x in its domain. Let's see what that looks like in practice, right? So f of x equals x. Let's plug in f of negative x. This is how you test this. If you plug in f of negative x, we just get negative x, right? We're replacing the function, which here is just x, with negative x. And so that is just sticking a negative on the original function. And so clearly this is going to be odd. Okay, let's go on with a different color here. For g of x, it's x squared. So we're plugging negative x in for x. Negative x squared just becomes x squared. So it becomes the function itself, right? So this is going to be even. Now, let's look at the graphs of these two functions real quick. So I'll sketch these out kind of roughly. X is just a line that looks like that, right? And so another example of an odd function would be x cubed, so I'll sketch that too. Right, and what do these have in common in terms of the graphs is that if we rotate them around the origin all the way around, then they're the same, right? So we have something called symmetry about the origin, or rotational symmetry. That is going to be something that all odd functions have. Now let's look at our even function, x squared. It's going to look like this, right? It's a parabola. So this is symmetric like over the y-axis. All even functions will be symmetric over the y-axis. Now let's look at our last function, h of x. We're plugging in negative x again. So we end up with negative 3x plus x squared. Now, is that even or odd? Well, okay, if we made, it's clearly not the same as h of x, right? Because the negative 3 of x it's a negative 3 of x instead of a positive 3x, sorry. And then it's not negative h of x either because x squared is positive. So this is going to be neither even nor odd. All right, so that is it for our intro to functions. If you like this video, please subscribe, and I'll see y'all next time.